Okay, let's start this class. And today we will review for midterm 1. And since we will have the exam on Friday, so on Wednesday we will start the chapter 2. But just remember, our midterm 1 is just for the chapter 1. Yeah, we will not include chapter 2. Yeah. Okay, let's try to review midterm 1, meaning the chapter 1. Okay. This is traditional. Firstly, we will review the basic concepts about signals, and to review the flag system properties, and then to help you prepare for midterm 1. Okay. We know the name for chapter 1 is signals and systems. What you can think about chapter 1? What you can remember since we have already. Yeah, graphs, yeah. Actually, you can see the name. We try to learn what is signals and what are systems and some properties, some different types of signals like that. Yeah, for the signals, what you can think about? Firstly, yeah, 3 classes. Yeah. Energy, power, and no energy or power, and also the period signals. And then what else? Yeah, periodic. If this signal is periodic or not periodic, and the city periodic or not. And we also learn something for the signals. Some, shift, scaling, and time reversal, try to transform the signals. Yeah, okay. What else for the systems? Yeah, some properties for systems, am I right? Yeah. Okay. Yeah, actually, we talk about the differential and the difference equations for system. Yeah, do you remember that form? First order equation and differential and difference equation. And for the transfer function and the impulse response, actually we just mention it a little bit, but this will talk about in the following chapters. Yeah, the chapter 1 tells us which systems we are allowed to analyze. Yeah, we mainly focus on the LTI system, and the later chapters and will teach us how to analyze those signals. Yeah, this transfer function and the impulse response function. Impulse response, we will talk about the transfer function. Do you remember where we talk about? Actually, when we talk about the inverse system, yeah, we talk about the transfer functions can help you easily find the inverse system. Yeah, and the impulse response actually it's related to the impulse function and the step function like that. This one can help you to deal with the signals. Yeah. Okay. And what else? Yeah, like you said, memory, memoryless, and causality, like causal or non causal, stable or non stable, TI. What does TI mean? Time invariance. Yeah, which means the system will not change based on the time change like that. Yeah, and the linearity. Yeah. Okay. And yeah. Sorry. And the basic signal and system representations for question 1 and 4. Actually, we will have 5 questions and 1 bonus. And the total will 122. Yeah. And do you remember we have a final exam waiver? Yeah. Which means every exam, if you greater than 90, yeah, and you can be, yeah. So I think it's now if you work hard and you will know. Yeah. Okay, let's continue. Let's try to review the. Can you see it clear? Yeah. Yeah, you can see the screen clear. Okay. And this is what we talk about for sufficient conditions when we discuss like which type of the system belong the signals belong with. And the first one, like the class one, like energy signals. What's the condition for the energy signal? Do you remember? What kind of signal we call it energy signal?
Oh. E is
Yeah, energy. Yeah, which means the energy should be infinite, smaller than infinite. Yeah, smaller than finite. Yeah, sorry, infinite. Yeah, and the power signal. What does that mean?
power.
Yeah, like the power should not be finite. Yeah, it is infinite. Yeah, and the case 3. Yeah, like the power should goes to infinite and the energy also goes to the infinite. Okay, let's talk about some. Yeah, the first signal, like the finite signal, the finite length. This kind of signal, which type it should belong to? Yeah, the first one, the first signal. The first signal. Yeah, belong to class 1. Yeah. Yeah, if you use the equations to prove that, you can prove that. But like this one is just like easy to tell you, like this kind of signals will belong to class 1. And which you can see here, this signal, it is a finite signal. Which finite signal, what does that mean? Finite signal. Yeah, the value, you can see the value is now infinite. You can see the value here is now finite. I'm right, it is now finite. And what is finite length? What does it mean? Yeah, the variable, like the t should in a range. I'm right. So this kind of signals, and it should belong to the energy signal, because you can see if you use equations to calculate the energy, it should be smaller than like finite. Yeah. Okay. How about the second one? The periodic and finite signal. Yeah, it's class 2. Just remember, almost periodic signals belongs to class 2. You can see, like I said, what does the finite signal mean? Finite signal. Yeah, non-infinite. Yeah, finite signal, which means the value is now finite. It's now, yeah, it's now infinite. Sorry, it's now infinite. Yeah, which means the value is has some specific, it will be smaller than some specific value. Here, it's now like talk about the finite length, which means here your time can be go to the infinite. That makes sense to you? Yeah. Okay, how about I will give you the answer. The third one also belongs to like the case 2, like power signal. Okay, yeah, this signal is just like a constant or convergent signal. Yeah. Okay, you can see actually the first signals, it also converge to will also converge because it is always smaller than the specific value. I'm right. It also converge to a value, and this one also converge to a value. So, what's the difference between the converge signal, the third type, and the first type? Do you remember? Do you remember? Yeah, actually, you can see this one converts to C, but there is a condition. C, yeah, doesn't equal 0. Am I right? But this one, there is no like this condition, which means for the first signal, you can try to this one. Am I right? Yeah, but the second, the third, maybe it will go like this. That makes sense to you? Yeah. Any questions so far? Yeah, okay. And the next signal definitely belongs to case 3, right? Yeah, because it will have the signal of infinite length that goes to infinite. Yeah. Any questions so far? Yeah, this is what we have already talked about. Okay, let's try to check this one. How about this one? How about this one? Yeah. What's UN function? What's UN here? What's the name for that function? Yeah, unit step function. What does that mean? Yeah, yeah. From 0 to infinity, it will be 1. Otherwise, it will be 0. Am I right? So which means your signal should be. Yeah, since a here is smaller than 1, absolutely smaller than 1, which means a, for example, it is counter 0, right? If a equals 0, what's the value? Sorry, 0. Yeah. If it is 1, huh? Because the n always the positive integer number, right? So if it's 1, what's the value? Counter 0, right here, and then 2, half, right? Half. It's just similar this one, this one, this one, this one, this one, this one. So what's the which type? History? Are you sure? You know. Yeah, but yeah. So, but we talk about that for this situation because this one will decrease, the value will decrease dramatically in a short time. All right. So these signals actually it belongs to one. Case 1, energy power, because the energy is limited. Yeah. Do you remember? Yeah, actually we talked about this. Yeah, how about this one? What does this mean? Yeah. Compare these two. What's let's try to observe the U negative n here. What does this mean? This is also unit step function, am I right? But what's the difference between this one and this one? This UN and U negative n? Yeah, just a flip. Yeah, because UN for UN, which means n greater equal 0 and UN will equal 1. Otherwise, it will be 0, right? U negative, yeah, like you talk about that, which means n negative greater equal 0, and it will U negative n will equal 1, right? Yeah, if negative n greater equal 0, which means n should smaller equal 0. that没sense去？没sense去？ Yeah, which means you need to draw the figure like this in this set. Your n should smaller than n. that没sense去？ your n should smaller than 0. that没sense去？ And then let's talk about the big n. Here, b, because b, absolutely b greater than 1. Let's consume it is 2. All right, you can 2 0. What's the value? 1, all right? Like 2, negative 1. Yeah, because it's always negative integer number. What's this? 2 negative 2 power negative 1. Do you remember yeah, 1/2? Like a 1/2. Yeah, do you know any number, let's try to, any number, a negative 1 equal 1 over a, you know this one, right? So which means this one actually is equal 1 over 2. This n greater than 0. Yeah, that makes sense to you? Yeah, so this one is just a negative 1. It's just this one. It's simply, yeah, and then 2, negative 2. Yeah, it's just similar with the same with the first, but the direction is just here. That makes sense to you. So which type? Yeah, it's just similar like this. Which type? It converts to 0, am I right? Yeah, it also converts to 0 from 1 to 0, but the n is just the different n. Yeah, so which type? Yeah, it is class 1. That makes sense to you? Yeah. Okay, let's try to see this one. Yeah, actually, when we learned this class, we didn't talk about so much unit step function, like because we haven't learned that before, but here, or to combine them together to talk about that. What is UT here? It's CT, unit step function. What does that mean? Like what's that? Which means t greater equal than 0, and UT will be 1. Am I right? And otherwise it will be 0, am I right? Yeah. So what is E here? Because A smaller than 0, E is what? E is what? Actually, you checked that before. Yeah, 2 point like 6 or a number, am I right? Yeah, let's consume it 2.5. And then, which means here is A T greater equal than 0, right? E here is smaller than 0, am I right? Which means let's give absolute here, and then we just this equation will become this one. That makes sense to you. When t equals 0, what's the value? When t is 0. Then when t is 0, this 1, am I right? Yeah. So this is 1. When t is 1, what's this? It will be 1 over 2.5, am I right? Yeah, because this is yeah, you can multiple but it will like 1 over 2.5 will multiple some this is I know your question. At when t equal 1, this is smaller than 0. When we add an absolute, like this is just some value like multiple t, it's still some t, am I right? Greater than 0, so some t, am I right? This is understandable, am I right? And then 1 over 2.5 value, actually it is a t. When t equal 1, it is just the at. Yeah, it will be 1 over 2.5, but the value, like power value, it will be smaller than 1. Yeah, you know that, right? Yeah, it will be smaller than 1. This is the T1. And T2, it will be smaller than when the T equals 1. Remember? So this image, it will just like this. So which type? Yeah, it is still class 1. Yeah, any question? Any question? Okay. And then how about this one? Actually, this one and the previous one is very similar. It's just like a flip. Am I right? Yeah. So what does that mean? Which means that when the t is smaller equal than 0, it will be 1. Other will be 0. Am I right? That makes sense to you? And then b here is greater than 0. Yeah, which means you just if you draw it, the image here is just like this. Yeah. But the previous is just like this, and the next one is just like this. So which type? Yeah, it is still class 1. Yeah. So, like, how about this one? What does this part mean? Which means what does that mean? You, if n greater or equal than 1, it will be 1. Am I right? Other will be 0, which means your like should be here 1. The 0 will not have like a value because n should not equal 0. And then n here, for example, if your n is 1, and p greater than p greater than like greater than 1. For example, let's let that equal 2. 1 power 2, what's that? 1, am I right? So which means when n equal 1, it is 1. It is 1, am I right? When n equal 2, for example, what's this? 1/4, am I right? So it should be like this. Maybe more smaller here. Which means this will decrease dramatically. Am I right? So which type? Yeah, also class 1. Yeah, actually you can use the equations to prove that all these things will increase, will belong to class 1. And then let's summarize, conclude that. Yeah, which means if you have one signal, and this signal goes to 0, am I right? Like converts to 0, and then it dramatically converts to 0. Am I right? It's not like this one. It's not like this one. So we don't know like when it will convert to 0. But you can see this those kind of signal, it will dramatically convert to 0. Am I right? That makes sense to you? Yeah, these kind of signals will belong to class 1. Okay, any questions so far? Okay, let's continue. Okay, let's talk about more examples about which types, which signals belong to which types. How about this one? Yeah. What's T? What's T's value? Time from negative infinity to the positive infinity, am I right? Yeah, it will be class 3 because when the T goes to the infinite and the value will go to infinite. How about this one? Yeah, it is class 1, but why? It is just a finite signal during a finite time. You can see, does it make sense to you? Yeah, because you can see UT, what's UT? UT is just this one. We know that MLT 0. What is UT minus 2? Which means T minus 2 equal greater equal 0. T greater equal 2, and it will be 1. 1, 2. And this one, this is UT minus 2. And this is UT. And those two minus together, it will be just this part. Does it make sense to you? Yeah, like this one minus this one. Yeah, it will just this left. And we know like the finite signal of finite length, it will be class 1. That makes sense to you? Any question? No? No question, honey? Okay. Question? No question? Okay. And let's continue. Okay, how about this one? Let's talk about what this. Still those questions, those figure, right? Those two figures, but here it's just a plus them together. If you plus them together, what's that? Like here is 1, right? And from here it will be 2, right? It just become this one. That makes sense to you? Yeah, those two add together, right? Yeah, what's this? It's just a signal convert to a, here is 2, convert to a specific value. Which type? Yeah, class 2. Yeah, because you can see we like a constant or convergent signal. I'm right. It will convert to 2. I'm right. Yeah. Okay. So this is 2. How about this one? Huh? Are you sure? Yeah, here is a G.
Oh,
Yeah, it is periodic signal. So 2. I'm right. Yeah, all the periodic, almost all the periodic signal will belong to type 2. Yeah. Okay. How about this one? Yeah. Here, what is T? T here. What's the value for T? greater equal than -2, am I right? It will from -2 to go infinity, positive infinity, am I right? And E is the 2.6 or yeah, and E power T, what's the value? Yeah, it will go to infinity. So yeah, class 3. Yeah. How about this one? Yeah. N, what's N here? All the like integer number, am I right? Am I right? Yeah. Like if N equals if N can now equal 0, 1 over. Yeah. If N equal 1, what's the value? 1, am I right? Yeah. If N equal 2, what's that? 1 over 2, am I right? If N equal 3, 1 over 3, am I right? If N equal 4, 1 over 4, am I right? So it will be just like this. Am I right? And but it can be negative. N can be negative. You know that, am I right? So in the negative, it will be -1. Am I right? If N is -1 here, and a negative half, -1 over 3, and -1 over, it's just similar like this. That makes sense to you? So which type goes to it will convert to 0? Yeah, dramatically. It should be class 1. That makes sense to you? Okay, how about this one? Yeah. Yeah, because it's periodic. Yeah. How about this one? What's the N here? Yeah, greater or equal than 4. And what is let's try this one. Yeah, since N will from 4 goes to infinity, right? So what's the value for this one? Yeah, infinity, because this one greater than 1, am I right? It will go bigger, bigger, bigger. Yeah. So which type? Yeah, class 3. Okay, how about this one? Yeah, you can see it's very similar, but the N changed. Am I right? Yeah, the N changed. The N, what's the value for N? What's the value for N? What?
Greater than 2.
Are you sure? Which means you can say this part should greater or equal than 0, am I right? So which means negative N greater equal than -2, am I right? So N should what? Less than equal 2. So this is the N. So N should from 2 to this one, to this direction, am I right? So this one 5 over N, and which means this value, when the N smaller than 0, this value should smaller, smaller, smaller. That makes sense to you? Yeah, it will go to the 0. Yeah, so this is 1, am I right? Yeah, so it's a tricky one. How about this one? Yeah, why? Yeah, it's periodic. Yeah, any questions so far? Okay, let's try to check the basic signal transformations. Okay, let's try to recall. What are basic signal transformations? We learned 3 types. What's that? Oh, what are those? Huh? Yeah. So many different. Yeah, you need to. Yeah. A general transformation is defined like this. Yeah. So then to obtain the transformations, yeah, this is just like the shift. This is the scaling, and the inverse here. If the alpha here is smaller than 0, which means it will be inverse. Am I right? So we know when we want to obtain the transformed signal, what's the first step? Yeah, just remember, do the shift firstly. Yeah, first delay or advance the signal, like do the shift. And then if beta greater than 0, it's last shift. It is smaller than smaller than 0, it will be right shift. Okay, that makes sense here? Yeah. Okay, then perform time scaling or reversal. Yeah. If here absolute greater than 0, greater than 1, it will shrink. That makes sense here? Yeah. If it's smaller than 1, it will be expanded. Yeah. Any questions so far? Yeah. Okay. So let's try check a problem. Okay, this problem, I don't know if you finish this one. Actually, this is a homework, but this one is maybe a little difficult to understand, so I want to review it. Yeah, consider a periodic signal, this one, all right? And with a period t equal to, yeah, because you can see from 0 to 2, and it will have this value. And the derivative of the signal is related to the impulse train, this one. And with period t equal to, it can be shown that this one, which means the periodic signal st and the impulse train has a relationship. This is a relationship. So the question lets you to decide what is A1, what is A2, what is T1, what is T2. Do you remember? Do you remember? No? Yeah, actually, maybe you haven't, but I will give you how to finish this homework. Yeah, first let's try to draw the xt. Here, this is xt. When the t from 0 to 1, it will be 1. From 1 to 2, it will be -2, all right? And also it is periodic, which means the every 2 it is repeat, every 2 it will repeat. This is t, this is xt, all right? That makes sense here? Okay, any question? And this is the impulse train. Why it is called a train? Because it's just like a train, like a repeat like that. And this is the like a no, this is not like a train. This is a derivative signal after for the xt. You can see when derivative, like only the change part will have value. All right. Yeah, the equal the flat part will not have value, will be 0, and the value for the like this edge will be infinite. We talk about that. Yeah, the edge part will be goes. So this is just like the derivative, the xt after derivative, and then let's talk about the train. Yeah, this is the impulse train. Why it is train? It's just like the same thing, repeat. You can see this is like a t like minus 2k, which means when only the odd number, even, the even number has a value. Am I right? When t equals 0, k is equal 0. When k is 1, t will go to 2 and it will value. That makes sense to you? Yeah, so it's just like this. This is 0, 2, 4. This is -2, -4. Am I right? Okay, so you can see from here, we know like how can we use gt to construct derivative xt. You can see here the 3gt, like if you like multiple, make it 3, and like minus 3g t minus 1, because you can see you need to construct this part. It will like a shift. This is a 0, this is a 0, this is a 2, and this is a 0, this is a 1, all right? So which means you have to shift. That makes sense to you? Yeah. And then you balance them together, and you will get this one. You will get the dt derivative t. Yeah. So which means your a1, a2 should equal 2, should equal 3, and your t1 should equal 0, your t2 should equal 1. Your a2 should equal -3. Yeah, that makes sense to you? Yeah. Okay. Any questions so far? Any question? Okay. Let's try to review the periodic signals. Okay. For the periodic signals, we try we just I show this table very often. And this is just like comparison, like the CT, DT, like exponential signals. Okay, this is CT exponential signals, and this is DT computational signals. What is the fundamental period for CT exponential signals? Yeah, 2 pi what? Okay. CT for the CT signals. 2 pi over.
Frequency.
Yeah, frequency. Yeah, what is frequency? Angular frequency. Yeah, it is equal 2 pi over omega. No, am I right? Yeah, we talk about that. And how about the periodic fundamental period for the DT? Like it is n equal to pi k over omega naught. Am I right? You need to write it in your cheat sheet. Yeah, for the midterm one. Okay. Yeah, and how about the fundamental frequency for the CT exponential signal?
We get a cheat.
Huh?
We get a cheat.
Yeah, you will have one. Yeah. Huh? You need to prepare it by yourself. Yeah. And yeah, I will talk about later. Yeah. And for the fundamental frequency, I think they will be easier because you have already have the relationship between the frequency and the period. So what is the fundamental frequency for the CT exponential signal? What is omega naught? Omega naught is the fundamental frequency. Yeah, that's right. Yeah, how about the fundamental frequency for DT? Yeah, actually it should, because we want omega naught, then we need to move this one here, and omega naught equal to pi k over kn, am I right? Yeah, but the problem is we wanted the smallest omega naught, am I right? So we just divided k here. So this is the fundamental frequency for the DT signal. Okay. Then for the relationship between the frequency and the oscillation, we know like for the CT signals, when the omega increase, the oscillation will increase. Yeah, we know like because the relationship between here, if you increase and your period will decrease, and then your oscillation will become larger. Yeah, that makes sense to you. Yeah, but for the DT, what's that? Do you remember? Yeah. Yeah, like the highest around 2k plus 1 pi, which means the highest is around pi, like 3 pi, 5 pi, 7 pi, am I right? And the lowest should like 0, like 2 pi, 4 pi, am I right? That makes sense to you? Yeah, do you remember? Okay, let me ask you a question. Whether adding two periodic signals will lead to a periodic signal, like two periodic signals plus them together will lead a periodic signal? Are you sure? Yeah, actually for CT, it is. You can see I have a periodic is this one is this one, the other maybe a T1, omega 1. The other is a T2 omega, T2 omega 2, and I added them together. It should be a periodic signal, am I right? But for the DT, you can see your N, because you need to make your periodic is an integer, like an integer number. So it needs like two different atoms have the specific rule. Yeah. So you need to pay attention to that. Yeah. Any question? Okay, this is the DT periodic signals, like a frequency, the relationship between the frequency and the oscillation. Yeah, we know like this is an example. Given DT, this one, and rank the oscillation rate for the following omega values from the highest to the lowest. You can see, we know like the oscillation rate will like from 0 to pi, it will goes up, and from pi to 2 pi, it will goes down, and then like repeat like this. Am I right? So I have 4. So which one is the highest? Which one? Which one has the highest oscillation? Huh? We know like the highest should happen to in when the omega equal this one. The lowest will happen when the omega equal, am I right? So when you close to this one, and you will have the highest. When you close to this one, you will have the lowest. Am I right? So which one is the highest? When your like omega now goes to this value, it will have the highest. So let's check that. Like a 4 pi over 9, because if here is a 4.5, it is half, right? So which means it is just maybe here, right? That makes sense to you. And 5 pi over 2, what is it? 2.5 pi, right? So which means it is half here, right? So 4 pi is just here. So the 5 pi is here. So which one is the highest? Yeah, this is the oscillation rate. Yeah, 5 pi is the highest because 5 pi is just exactly equal to this one, right? Which one is the lowest? Yeah, 4 pi is the lowest. And which one is like a middle? This one. Let me compare this one. Which means this one is half, right? Half to this one, and this one is small. It's greater than half. The distance is greater than half, right? So which means this one will has a further distance compared with pi, and this one is compared with 3 pi. It has half. So those two, which one is the highest? Yeah, the 5 pi over 2. That makes sense to you? And the next will this we compare those two, and this is the smaller one. Yeah, understand? Any question? Okay, yeah. Okay, let's try to review 5 system properties. Yeah, we have memory or memoryless, chiral, non-chiral, chirality, stability, time invariance, and linearity. I will now review all like a specific one, and I will give you some equations. Yeah, the memoryless, which means the output only depends on the present input. That makes sense to you? Am I right? Yeah, and the chirality is just like the output just depends on the present input and the previous input. Am I right? Yeah, and the stability is which means the bounded input result in bounded output. And the time invariance is just like if your input result output and your input after shift and you have the same shift for the output. Yeah, this is the time invariance. And then the linearity, which means if you have the linear combination for the input, you have the same linear combination for the output. Yeah, this is, and for the time invariance and the linearity, we have like a 4-step way to improve. Yeah, to prove, like, yeah, if it is linearity or time invariance. Yeah, any question? Okay, and then we try to check this one. And we know this, if this one is a linear like a vector about the input, it will be like a linear. Here we talk about the LTI system, which means this system is linear, like a linear, it has a linearity, also has a time invariance feature. That both have works for this equation, which means this vector should have the linear function, and this is a constant coefficient, and this is a no scaling factor. Yeah, so how about this one? Is it a LTI system? No, what? Yeah, because sin is non-linear function, am I right? Yeah, how about this one? No? How about this part? Oh, yeah, no, sorry. Yeah, because you can see this is also like this is a constant coefficient, right? Yeah, but here it's not a constant coefficient. Okay, how about, yeah, I have already used it. Okay, yeah, this is also no, because this one should no scaling factor, which means it must be one, not two, not three, no other things. Am I right? Yeah. How about this one? Yeah, this one is also, this one it is. But this one, there is a power here. That makes sense to you? Yeah. So, but when I want you to prove if this system is a linear, if it is LTI system, you'd better to follow that four-step method. Okay. Yeah. How about those equations? Yeah, actually, we talk about all CT-DT systems that can be written as a constant coefficient differential or difference equations are LTI system. Am I right? We talk about this. Yeah, actually, we talk about the first order, but the second order also works. Yeah, here is a second order. Second order. Yeah, also works. Yeah, all the CT-DT systems that can be written as constant coefficient differential or difference equations are LTI systems. Yeah, no matter it is first order, second order, third order. Yeah. Okay, let's try to check question. Actually, we will have the similar question in the midterm one. Yeah, just pay attention. Give a LTI system with an input output like a pair X, Y can result. If your input is this one and your output is this one, then I give you the other input X2T, and I ask you to decide what is Y2T. How can you do that? Yeah, this is LTI system. Yeah, the key is to use X1T to represent X2T or X3T via LTI properties. Then you can find Y2T or Y3T from Y1T in the same way. Actually, you can see, we know like the LTI system, if you have the like linear combination for the input, like A, X, Y, T plus B, X2T, and then you have like A, Y1T plus B, Y2T, right? Yeah, we have this one. Actually, you can see, here you can change it. Also Y. This is also Y, am I right? And that makes sense to you? Yeah, so which means the point is we find how can we use XYT to represent X2T? You can see how. It just tell me like we use what? You can see if we want to use the X1T to represent X2T, here it just must equal X1T plus something, am I right? Plus one part, am I right? Yeah, so what we found is just we need to find this one, am I right? What is this one? This one is just after we shift and then flip based on the axis, am I right? So which means we can get this equation. That makes sense to you? Yeah, x, y, x1, 2 is the original one. And this one is after we shift and then we flip. That makes sense to you? Yeah, so then because it is LIT system, so Y2T equals a similar formation, like a similar style, similar like form. Yeah. I didn't show it to you. Yeah, so it should be this one. Yeah, so let's try to stretch Y2. Yeah, because this is Y1 here, right? And then this is a Y shift and then flip. That makes sense to you? Okay. Then there is the other one. Let me give you the other sorry. Yeah. The other like example. Yeah, but this is just like a similar thing. Yeah, but it will have involve scaling. Yeah, this one will be the X3T. That means yeah, you can try to, yeah, because you can see I have X1T and yeah. Also, I shift it here and plus them together. It will be like this. That makes sense to you? Any question? Okay, then the Y will have the similar form. So you can stretch the Y3T. Yeah. if you draw it, you need to add them together. Yeah, like this. That makes sense to you? Yeah, those two are very important. It will be like occur. It will occur in the like midterm 3. Okay. Yeah, this is a homework. Just remember, if your why this is not here because it involves change the time. Why it is not linear because it involves to change the system. We talk about it when the signal will change, it will not linear. When the time will change, it will not ti. Yeah, we talk about that. Okay. Yeah, this is for the one-page note sheet requirements. Yeah, what in power basic equations, the major steps to solve the problem, mathematical definition of properties. But no example problems discussed in the classroom and in the class homework problem as the exam problems. Yeah. So I will like the homework and the like all the questions we talk about in the class. Maybe I will change a little bit and put it in the midterm 1. Yeah, that's if you have any questions, just let me know. Okay. Oh. Huh? Yeah, 5 and 1 bonus. Yeah.